Hi everyone, welcome to G World of Academic Physics. Already we have discussed the Model 1, Model 2 and Model 3. Today we'll go for the Model 4, the basic fundamentals questions of electrostatics. What is the question is asking here? Q and 4Q, two charges at a distance r apart, where the third charge I will placed so that the system in equilibrium, this is very important word, so that the system in equilibrium, if the system in equilibrium, find the nature and polarity of that third charge. Nature means find the, here I can say magnitude. Rather than nature, I will write here magnitude. Find the magnitude of this third charge as well as the sign of the third charge so that the system in equilibrium. If you go to the model 3, already we have discussed, suppose this is charge Q, this is 4Q, and these two charges at a distance r apart, then exactly the third charge will be placed at a distance of r by 3. I will suggest please go and check the model 3 so that you can easily understand the things. So where I will place my third charge? Third charge I will place nearest to the smaller charges, and it is exactly at a distance of r by 3. And I said suppose this is third charge. I don't know exactly the magnitude of this third charge, and I will check also the polarity of the third charge if the system in equilibrium. This charge already in equilibrium, but we are talking about the system in equilibrium. System having three charges. This charge already in equilibrium. Other charges must also be in equilibrium as already the system in equilibrium in the question said. So look, a other charge, I will say look at this charge. If the system in equilibrium, the net force on this charge must be what? 0. So force due to this and force due to this must be equals to what? Must be balance each other. So I will write due to this. Carefully see what I will write. I will write in magnitude form K Q upon R by 3 whole square. Must be equals to what? K Q due to this force 4Q upon what? R square. This is K Q cancel. So 1R square here also cancel. This goes to 9. So 9Q. I'll say what? 9Q. This is 9Q equals to what? 4Q. Then this Q equals to what? 4Q upon 9. So this is the magnitude of this third charge. This is the magnitude of the third charge where the system in equilibrium. Now we'll think about the polarity of this charge. Either this charge is positive or negative. We will look into. Carefully observe. First I will consider if this is positive. What will happen? Positive. Attract or repel. It will be like this. Positive. Attract or repel like this. It means this charge is not in equilibrium. If I consider this is Q, this is 4Q, and I will consider this charge is negative Q. What is the scenario will come? Look at this charge. Positive, negative, it will what? Attract this charge, and 4Q, it will repel like this. So as we are looking the system in equilibrium, so net force on this charge must be 0. This charge pulls this charge like this. This charge pulls repel this charge like this. So net force on this charge is 0. So what should be the polarity of this charge? Already this polarity should be negative. I must put a negative sign in my answer. I hope the scenario is clear. Look at one more illustration to give the confidence. Suppose I will consider a charge. I will consider a charge what? Suppose I will consider any random 9Q. This is Q. And this is at a distance, I will say at a distance r apart. At a distance of what? R apart. I already know my concept point of view. The third charge is always nearest to the smaller magnitude charge. Here the magnitude is 9Q. Here it is Q. Magnitude is 9Q. Here it is q. So it will nearest to the smaller charges, and already I said if the polarities have been different, then it will be at a it is outside. Where it will be lies? Outside. If this is r, I will say this distance is x. First I have to find this distance x. So what I will do, using that model 3, I will write the net force on this third charge. So this is k q upon x square, and this is k q 9q upon r plus x whole square. So what are the things have been coming? K cancel, q cancel, k cancel, q cancel, and q also cancel. So 9x square is coming what? R plus x whole square. And little good way if I'll think, this is 3x equals to r plus x. So 2x equals to r, x equals to r by 2. So where the third charge I will place, so that the third charge in equilibrium, I will say the third charge, it will be, the scenario is like this. This is 9q, this is q, and it is exactly at a distance of r by 2, and it will lies outside. And this distance is r. But the question is, system in equilibrium. System in equilibrium means this charge already in equilibrium and it is lies outside, but I have to think about the other charges must be also equilibrium. Let's consider this charge. If I consider this charge in equilibrium, force due to this and force due to this must be equal. So force due to this can I write as k q 9q, sorry, this is 9, this is q, upon what? R square, equals to what? K q, capital Q, upon r by 2 whole square. This is the scenario. So what are the things have been coming? K cancel, q cancel, it is there. So 9q and r square here cancel. So 9q equals to coming 4q. So what is the value of q? That is 9q upon 4. This value is coming what? 9q upon 4. The magnitude of this third charge, so that the other charges are equilibrium, the magnitude is 9q upon 4. Now we'll think about the polarity. If I consider this is a positive charge, see carefully, this is positive, force on this charge, it will repel like this. And due to this is negative, this is positive, it will attract like this. This charge will move like this. If I consider this is as a negative charge, look at this point. Negative, positive, it will repel, it will attract like this. Negative, positive, it will attract like this. This charge will attract this charge like this. So now one can predict what is the polarity of this charge, third charge. The magnitude is these things, but the polarity is negative. So what should be my answer? Q equals to 9q upon 4. This is the real answer that I have to be my checklist. Let me summarize what we did. Using the model 3, we know that equilibrium point always nearest to the smaller charge. First, you have to find at what distance you will get the equilibrium point. Once you get the equilibrium point, you will look into the other charges must also in equilibrium as the system in equilibrium. So I just look the other charge, any of the charge you can prefer. I prefer this charge, and I will write the net force due to other two charges, and I will make it equal, and I will get the magnitude of the charge. And the second most important thing, I will check the polarity. Take it in your own mind way, that positive or negative. Look at this. If this is negative, this is positive already, here attract, here repel, the net force is 0 for this charge. That's why the polarity is negative here. Similarly, the similar fashion, we have done these questions and we reached the conclusion the polarity is negative and the magnitude is 9q upon 4. So total answer if I will write, so q equals to 9q upon 4. This is very important, and most of the engineering exams, this question has placed in the old papers. Thank you everyone. Thank you for your watching.